Lecture notes by Dr. Ali Hijazi. Gears, page 1 of 12. Gears are among the most important power transmission elements. A gear is a rotating machine element having cut teeth which mesh with another toothed part, usually having teeth of similar size and shape. In order to transmit power, two or more gears working together are called a to the power of or gear set, and can produce mechanical advantage to the power of and thus may be considered a simple machine. The mechanical advantage is a measure of the force or torque amplification that is obtained using mechanical devices. When two gears mesh with one gear bigger than the other, the size of the teeth must match, thus the bigger gear has more teeth. A mechanical advantage is obtained where the rotational speeds and the torques of the two gears will be different, since the input and output power must be equal. Ignoring friction losses, there is an inverse relationship between the speed and torque ratios. The small gear will have higher speed and lower torque, and the larger gear will have lower speed and higher torque. A transmission or gear set can be used to change the speed, torque, direction of rotation, direction of a power source, or the type of motion. The most common configuration for a gear is to mesh with another gear. However, a gear can also mesh with a non-rotating toothed part, called a rack to the power of, thereby producing translation instead of rotation, as shown in the figure. Such arrangement is referred to as rack and piny to the power of, and it is commonly used in the steering systems of automobiles. Types of gears. There are four principal types of gears. Spur gears, the simplest type of gears. The teeth are parallel to the axis of rotation, as seen in the figure. It transmits rotation between parallel shafts. Men 204. Mechanical drawing. Lecture notes by Dr. Ali Hijazi. Gears, page 2 of 12. Helical gears. The teeth are inclined with respect to the axis of rotation, as seen in the figure. Same as spur gears, it transmits rotation between parallel shafts, but it is less noisy than spur gears because of the more gradual engagement of the teeth during meshing, and thus it is more suitable for transmitting motion at higher speeds. In some cases, helical gears can also be used to transmit rotation between perpendicular shafts, as seen in the figure. Bevel gears. The teeth are somehow similar to those of a spur gear, but they are formed on conical surfaces instead of cylinders. Bevel gears transmit rotation between intersecting shafts. The gear shown in the figure has straight teeth where this is the simplest type. However, there are other types where the teeth form circular arcs, and it is called spiral bevel gears, as shown in the figure. With spiral bevel gears, the teeth engagement will be more gradual, similar to helical gears, and thus it is less noisy, and it is suitable for higher speeds. Worms and worm gears transmit rotation between perpendicular shafts, not intersecting. There is an offset between them. The worm resembles a screw which can be right-handed or left-handed. Worm gear sets are usually used when high reduction in speed is desired. Speed ratios of 3 or higher. It transmits rotation from the worm to the worm gear, but not the opposite. Nomenclature. Since spur gears are the simplest type, it will be used for illustration and to define the primary parameters of gears and their relations. The figure illustrates the terminology of spur gears. Pitch circle, the theoretical circle upon which all gear calculations are based, and its diameter is called the pitch diameter to the power of. Men 204. Mechanical drawing. Lecture notes by Dr. Ali Hijazi. Gears, page 7 of 12. Gears standards. Usually, gears are designed based on standards established by ISO for metric sizes or ANSI for inch sizes. The standards specify the different parameters used to define the geometry of gears, such as module, addendum, dedendum, tooth thickness, pressure angle, etc., and the relationships between these parameters. The standards were developed to attain interchangeability of gears having the same pressure angle and module or diametral pitch. Regardless of the number of teeth, the table gives the preferred values of module and diametral pitch according to the ISO and ANSI standards. Gear manufacturers make a large variety of standard-sized gears, and such gears can usually be available as off-the-shelf components when a standard gear is chosen. The gear is usually not shown in full detail in technical drawings, as shown in the figure. Instead, a schematic representation is used, and the gear is defined using its geometric parameters. Detailed drawings of a gear are made when a special gear is designed or when gears in assembly must be shown. The geometry of a standard spur gear is defined by 4 parameters: module or diametral pitch, pressure angle, number of teeth, and face width. A standard ISO spur gear having a module of 4 mm, 25 teeth, 20 to the power of degrees pressure